Okay, let's start with talking about wind. We talked about wind last week. We're going to add a vertical component to air motion this week. Vertical velocity. Vertical velocity influences much in the way of weather. It causes clouds to develop. It may cause your flight to be bumpier than you expected. It brings clear skies. It'll even bring thunderstorms. So we're going to go into it just a little bit about what causes vertical motion. Remember this, the atmosphere is a fluid. So if I pushed in a water bottle at the bottom of a water bottle inwards, that would have an impact at the top of the water, right? Well, the same thing is going to happen in the atmosphere. We have a fluid. So if I have winds converging at the surface, they can't go into the ground, so they're going to tend to go upwards. If convergence just means winds are coming together. So if I had the same thing in the upper levels of the atmosphere, if they're coming towards each other, or say one wind is faster than another, so it's that air parcel is catching up. Well, because the stratosphere is so stable, the air can't go up into it. So what that means is it all goes down. It comes down, it would sink, we'd have clear skies. By the opposite effect, if I had wind that wasn't quite as strong and stronger wind out ahead of it, that wind would be pulling it apart. The air parcels will further apart. Remember, the atmosphere does not like lower pressures, really. It tries to do everything it can to get rid of the pressure being lower there. So what it's doing is causing air from below to rise up to take its spot. And that's what we've got here in this little thing we're looking at here. And you can see here you have different components of wind upward motion. Wind orography plays a role. If you're flying into the Rocky Mountains, as you're flying in towards it, the winds are coming out of the west, the air is probably sinking on the east side of the Rockies and rising on the west side. So you can see the different components here of the wind speeds. Fronts, you're rising up a warm front or cold front. Now, we want to talk a little bit about stability. And stability really is, think about a hot air balloon. If you have a hot air balloon, it's rising up as it's moving. Why is it rising up? Because the air is less dense than the air around it. So it's going to rise up until it gets to the same temperature as the air parcel around it. Not happening with a hot air balloon, but air parcels. Take any size of air you want, size of your airplane, and you start raising that air up because it's hotter than the surrounding air. What's going to happen? It starts expanding. And at some point, it may become cooler than the surrounding. That's the whole point of stability. Stability is going to rise up quick, faster. It's accelerating the air parcel up when it's unstable. And if the parcel is stable, it's accelerating the air parcel down. All stability is, you're looking at the temperature around that parcel of air to see if it's warmer or colder. So let's look a little bit at some stuff here today. Obviously, we have some vertical motions going on across Texas today and along the Gulf Coast, right? So that is the area. If you were flying today in this area, you'd have some issues. So with that, what is going on about today? The surface analysis. Well, what we have here is basically a stationary front across the south part of Texas. And I mean, it is moist out in the Gulf of Mexico. Dew points, which are a measure of moisture. And we're talking about moisture this week. Moisture can change state in the atmosphere. It's the only element that can change state within the atmosphere is water. So, yes, it can be water vapor. You're not going to see it. It can be a cloud, liquid. You're going to see it. It can be snow or ice. Probably part of the upper level clouds and the high up in the atmosphere. More ice than snow. So it can be any one of those three states. So what we see here with clouds is a reflection of water vapor changing from water vapor to a liquid. Now, today we have what looks to be a relatively innocuous pattern here. We have a front along the Gulf Coast. Not really much happening here. A little bit of a weak boundary here. All right, so what is happening? What is causing some of these clouds? Well, this is upper air, and you got to be familiar with the atmosphere is three-dimensional. I've talked about it. The winds are blowing from west to east, like normally, but notice how the winds kind of shift in this part of Texas right here. And with that, the yellow areas are calculated divergence. So there's divergence at 300 millibars. What that means is the air below it is going to want to rise. Well, what did we see here on the satellite image? Wanting to rise. So we're getting these convection here because of the surface air is diverging. Not necessarily as much at the surface in this case. We can look more at this and say I was curious about stability. Here we have a temperature plot. A temperature is plotted along the x-axis, and instead of being straight up and down, we skew them to the right. It's called a skew T for that reason. It's skewed 45 degrees to the right. So here's minus 30, it goes like this. Minus 20 goes like this. All you're doing is plotting temperature. Pressure over here on the left. And yes, we push the pressure levels a little closer together, like they are in the actual atmosphere. They're closer together in the bottom. And remember, as they go up, they get further and further apart. The air spreads out more. So with that, we plot a sounding, which is literally a vertical representation, and this is at Corpus Christi, of the air. So at Corpus Christi today, we have dew points here and temperature here. So we're, not too far apart, but a little bit until you get further up. We talked about lapse rate and an air parcel. Well, say I rose an air parcel dry 80 abatically. That would mean it would cool at 9.8 degrees Celsius, right? Well, if I did that, probably over in here somewhere, this air lapse rate temperature is definitely not as fast as 9.8 degrees Celsius. So that would mean it would be stable. Drop back down, no clouds. Now, if I add moisture and say I have that moisture condense into a cloud, something lifted it, and we have a front down by Corpus Christi, so we know we can get lift there. I am going to go up a moist adiabatic lapse rate, which is this line right here. Notice how far to the right, how much warmer it is than the environment air around it. That means it's unstable. If I can get this air parcel to become cloudy, I can then lift that air parcel very quickly upwards, all the way up to where it hits the troposphere, the tropopause up in here. So you can see stability plays a role in the vertical motion of that air parcel. Finally, I just wanted to look. There is tons of moisture along the Gulf Coast, and there is a lot of moisture right here. So finally, I just wanted to go a little bit back to the GOES satellite to give you an idea. We have all this moisture advecting up and over. Notice how sea breeze front right along here is already beginning to form clouds and possibly even some thunderstorms later today. We saw that sounding down there in Corpus Christi. So this is what's happening in Texas right now. So when you're looking at METARs this week, you're going to be able to observe, looking at the METAR down in Texas, for example. Oh, skies are cloudy, 73, 72. Wow, dew points are real close to each other, very moist. Front right there, you can see it. We actually have two dots here. That's rain, light rain. Three dots would be moderate rain. And if we were to look in your textbook this week, we've just talked about stability and all a little bit here in the UTs. And we have all kind of different wave motions that are based on stability and atmospheric things you're going to be learning about. And we did talk about lapse rates. And with that, we talked about you're going to be seeing things as a pilot. When you're observing how your aircraft's behaving, maybe you can feel up and down motions from turbulence. Maybe you'll see, oh, why are those clouds out there ahead of me? And if you see them rising quickly, well, then you know you have some instability. So with water, one of the things I do want to mention is for water vapor to become a liquid, there is more energy in water vapor than there is in a liquid. So heat is released into the atmosphere when it condenses. Now, by the same token, if you see a puddle on the ground and you wondered, oh, why is that puddle going away? It's evaporating. If you were to go very close to that puddle, it would be slightly cooler than areas around that puddle. The same thing would happen with a big water mass as well. So that'll help you with temperature, which impacts stability and wind motion. We have sea breezes. We've talked about them before. We have mountain breezes. All of these are impacted by the stability with it and how temperatures change due to change in state of water. So I hope you get a little bit out of this and can see how some of this interacted today over Texas. And let me know if you have any questions.